In 1939, a revolutionary fighter aircraft emerged from secrecy, its sleek form hidden from prying eyes, awaiting its maiden flight with the promise of rewriting the rules of aerial combat. The Lockheed P-38 Lightning, with its twin booms, twin engines, and turbochargers, was unlike anything the aviation world had ever seen. It looked like a machine from a science fiction tale, a bold departure from the conventional designs of its time. This aircraft wasn't just built, was crafted as a mechanical beast, designed to dominate the skies with unprecedented speed, range, and firepower. At the heart of its creation was a young aeronautical genius named Kelly Johnson, whose vision and tenacity not only birthed this iconic plane, but also laid the foundation for Lockheed's legendary Skunk Works, the secretive division that would redefine innovation. This is the story of the P-38 Lightning, a fighter that pushed the boundaries of engineering, challenged the limits of technology, and carved out a unique place in the history of World War II. The story of the P-38 begins with Kelly Johnson, a 27-year-old engineer whose brilliance secured Lockheed's first military production contract in 1937. Johnson's rise at Lockheed was nothing short of extraordinary. He joined the company as a humble tool designer, but his intellect quickly set him apart. At just 23, he identified a critical flaw in Lockheed's upcoming Model 10 aircraft, convincing senior management that its tail design was unstable and required a complete redesign. His proposal to switch from a T-tail to an H-tail proved correct, saving the aircraft from potential failure and earning him respect far beyond his years. By 28, he was Lockheed's chief research engineer, and by 29, he was leading Skunk Works, a clandestine division built on his philosophy of efficiency and innovation. His mantra, "Be quick, be quiet, be on time," became the guiding principle of Skunk Works. Cutting through bureaucratic red tape and fostering a culture of rapid, focused development. Johnson's ability to innovate under tight budgets and even tighter deadlines made him a legend in aviation history. The P-38 was his first major triumph, a stepping stone to later iconic designs like the U-2 spy plane and the SR-71 Blackbird, cementing his legacy as arguably the greatest aircraft designer of all time. The P-38 was born in response to a formidable challenge issued by the United States Army Air Corps in 1937 through Circular Proposal X-608. The Air Corps demanded a high-altitude interceptor capable of reaching 360 miles per hour, 580 kilometers per hour, and climbing to 20,000 feet, the cruising altitude of bombers, in just 6 minutes. These specifications were so demanding that most American aircraft manufacturers dismissed them as unattainable. At the time, Lockheed was a struggling civilian aircraft company in depression-ru America, teetering on the brink of obscurity. Yet Johnson saw opportunity where others saw impossibility. His radical design for the P-38 was one of only 2 submissions for the contract, and its audacity propelled Lockheed from a floundering enterprise to the world's largest defense contractor. The P-38's success was a turning point, transforming Lockheed into a powerhouse of military aviation and setting the stage for decades of innovation. The design of the P-38 was a radical departure from convention. Johnson and his team explored countless configurations to meet the Air Corps' requirements, sketching everything from traditional twin-engine setups with wing-mounted engines to bizarre, symmetrical designs with cockpits offset to one side. Some concepts proposed placing both engines in the fuselage, driving wing-mounted propellers through drive shafts to centralize weight and improve agility, much like an ice skater pulling in their arms to spin faster. These designs aim to reduce weight on the wings, enhancing maneuverability in turns. However, such configurations posed significant challenges. Housing 2 engines in the fuselage would require an impractically long aircraft, and the drive shafts and gearing needed to transfer power to the propellers would be complex, heavy, and difficult to maintain. After exhaustive exploration, Johnson settled on a configuration that was both radical and elegant: a central fuselage with no engine, flanked by twin booms housing to Allison V-1710 V1 engines. This left the nose of the aircraft free for an unprecedented armament: 4.50 caliber machine guns and a 20mm cannon. It's all aligned to fire straight ahead. This nose-mounted weaponry was a game-changer. Most World War II fighters mounted their guns in the wings, where space was more plentiful, but aiming was problematic. Wing-mounted guns required pilots to aim at a convergence point, where the bullet paths from each wing crossed, creating a narrow zone of maximum effectiveness. If the convergence point was set too close, the bullets would spread rapidly beyond that range, making long-distance shots ineffective. If set too far, close-quarters dogfights became challenging, as the bullets wouldn't converge in time to hit fast-moving targets. Pilots often had personal preferences for convergence distances, forcing ground crews to manually realign the guns for specific missions. Time-consuming process that could delay operations. The P-38's nose-mounted guns eliminated these convergence issues entirely. With all weapons firing straight ahead, pilots could aim precisely at any range. From close dogfights to long-distance strafing runs against bombers or ground targets. This gave the P-38 a significant advantage, rivaled only by the German Bf-19, which mounted a cannon that fired through the engine's propeller hub, aided by an interrupter gear to avoid shooting its own blades. The P-38's armament was formidable, comparable to heavyweights like the P-47 Thunderbolt and the German FW-190, both of which struggled with convergence issues. It wasn't until the introduction of the Me-262, the first operational jet aircraft in late 1944, that the P-38 was truly outgunned. However, the Me-262's early turbojet engines were unreliable, and the P-38's combination of firepower, speed, and range kept it competitive. The aircraft's twin Allison V-1710 engines, each equipped with a single-stage supercharger, were compact and powerful, but struggled at high altitudes compared to the British Merlin engine, which featured a two-stage, two-speed supercharger. To overcome this, Johnson integrated General Electric B-33 turbochargers into the P-38's twin booms. Unlike superchargers, which drew power directly from the engine's driveshaft, turbochargers used exhaust gases to spin a turbine, boosting compression without sapping engine power. This allowed the P-38 to operate effectively above 25,000 feet, reaching speeds of 360 miles per hour and, with external drop tanks, achieving a range exceeding 1,300 miles, far beyond what other fighters could manage. Cooling was a persistent challenge. The P-38's liquid-cooled engines were sleek and streamlined, unlike the bulkier, air-cooled radial engines of planes like the P-47, but they were vulnerable to damage. A single bullet could sever coolant lines, crippling the engine. To manage the heat generated by compressed air in the turbo-supercharged system, Johnson devised an innovative solution: intercoolers integrated into the wing's leading edges. Air entered small inlets, flowed through a network of tubes to cool the turbocharged air, and exited through vents at the wingtips. This design minimized drag compared to traditional intercoolers, which relied on large, drag-inducing air scoops. However, as engine power increased during the war, the P-38's cooling system struggled to dissipate heat at full throttle, requiring pilots to carefully monitor engine temperatures to avoid damage. The P-38's tricycle landing gear was another forward-thinking feature. Unlike the taildragger designs of most contemporary fighters, such as the Spitfire or P-51 Mustang, which had two main wheels under the wings and a small tail wheel, the P-38's tricycle gear included a nose wheel, providing better ground visibility and stability. Tail draggers tilted the nose upward, obscuring the pilot's view during taxiing, takeoff, and landing, and were prone to tipping forward on rough surfaces, risking propeller damage. The P-38's tricycle gear made it easier to operate on the makeshift coral and dirt airstrips of the Pacific Theater, where a broken propeller could ground a plane for weeks due to limited support infrastructure. This ruggedness and versatility made the P-38 a standout in the island-hopping campaigns of the Pacific. World War II aircraft design was a battle against thermodynamics, compressing air to extract more power from fuel-generated intense heat, risking pre-ignition and catastrophic engine damage. Liquid-cooled engines like the P-38s required radiators to dissipate heat, while air-cooled radial engines prioritized durability over aerodynamics. The P-38's turbo-supercharged system was cutting-edge for 1939, but it lagged behind the Merlin engine's two-stage, two-speed supercharger, which offered optimized performance at multiple altitudes. The P-38's single-stage system was tuned for 20,000 feet, giving it a slight edge over the Spitfire at that altitude, but limiting its effectiveness elsewhere. For example, the P-40 Warhawk, which used the same Allison V-1710 engine without a turbocharger, struggled at high altitudes, peaking at 15,000 feet. The P-38's turbochargers improved high-altitude performance, but the system's complexity introduced turbo lag as exhaust pressure took time to build.